Welcome back to our Python lectures, and today we will look at the Python standard library. So this is a standard packaging, standard modules which come with Python installation. So things we can do already if we have Python installed. We will need to use some additional instructions such as import anti-gravity, right? And in order to get something done. In fact, that's a real command, except you won't fly. So again, this is part of our code repositories, and talk about how standard library resources. Again, where do you find it? Well, you can look at here. This will be, I think, slightly old. This will be Python 3.9, I believe, right? You can look at here, actually. Official library is here, I believe, right? That's the official documentation, but you probably want this one here, which is, right, different cool modules, right? And also another side is probably this one's better, right? Well, yeah, that's the same one actually. So this, it's a little bit dry, this official documentation, right? But slightly again includes everything that comes, sort of say, like I said, batteries, you know, on the kitchen sink are included. We'll look some of the popular libraries. So what I'll be using still, we'll be using notebooks, right? Today, still using the Google Colab link. Anybody can follow along and get some idea. So I will also add some extra instructions. Maybe you'll have a newer version available. So afterwards, right? This is official location, right? So what happens is basically we use the import command. We've been using it before a couple times, right? So what happens basically, well, we tell the Python to look for this particular package. Again, so what's package, right? Well, it's a collection of modules. Well, what's a module then? Well, module is basically a Python file, so which includes some functionality, right? So when I'm importing string, right? Okay, I'm saying it's not authored by Google, so it's authored by me, right? So what do I gain? What kind of access do I get? Well, first I need to load the machine. Okay, and I have plenty of RAM, everything, and I get access to things like this. So this is mostly a very, you could say, slightly boring library, right? Because it includes some things like punctuation, like some constants. For example, I'll add one more cell. Let's see here, where are we? Right here. No, that goes down. We'll add here, we'll make a new cell, new code cell. So string, I type dot. I'm assuming my connection to Google is pretty fast. Well, again, this will work in most code interactive, you know, development environments, right? You'll have access to different, well, capabilities. Like you have usually some methods, and mostly you have lots of well, properties, right? So for example, lowercase, or maybe you have a white space digits. So digits will be, unsurprisingly, it will be all the digits. You may ask why. Well, why do you need to have this? Well, you don't really need to use this, but you're pretty much guaranteed what Python considers a punctuation in English. It will be included here. So if we ever decide to have add an 11th digit, well, some new symbol for a digit, maybe then the change should be reflected here. You don't have to come up with your own, because, well, you are more maybe likely to make a slight typo somewhere, right? Again, so some constants, it's not crucial. Again, you can do all of these things by yourself, but you gain this ability, right? So let's look at some more interesting modules. Let's take a look at the datetime module. So this is one of the important libraries if you ever want to work with dates and timings. Well, because it's easy. It's extremely easy to make mistakes when calculating time zones. We have leap years, we have daytime savings. So it's quite important to have a good library to work with it. Well, the only slight problem with this library, I'll show you, is that it has this, well, double datetime syntax. It's one of those, I could say, it's a slight, I could say, not a fault, but maybe, well, design choice, which was not maybe perfect. Well, nothing is perfect. So we have a library called datetime, which includes a datetime, well, class basically, right? So on which you have a node which has a method, right? So And what this gives you, it gives you the current time. So let's run it. It will be this year 420, right? So we gain ability to have a specific machine independent time, right? Quite useful, right? So, well, you see some other things here too, right? It's 4th of April. Well, let's see, where did 13 come from? We have 7, right? Maybe there's some timing. Well, this is on Google servers, right? In England, actually, looks like, right? That's 3 hours earlier. So this certainly looks like this data center is in England if you are working with a Google machine. If I'm running this code on my local machine, it would be certainly be actually local to me. So of course, Python has no way of knowing in which time zone you are, but it will use the machine local one for me here, for example, right? So, but the question is now, if you want to see how much time has passed from then and now, right? This is then maybe, right? We can do, well, have a time passed ability, right? So, which is of course, say seconds, microseconds, well, very precise, microseconds being, well, 1 millionth of second, right? So you have 57 seconds and 700,000 something microseconds. You can get out of this object, you can get 57 seconds, and you can of course get also maybe time past days. Well, nothing, no time has passed, well, because days have not passed. So if you need specific time past hours, as you can imagine, there should be one. Let's see, dot, I type dot, and I get days. There should be hours too. Maybe it's not using minutes. I thought there would be an hours, right? Of course, I'm guessing, right? So minutes apparently, right? And minutes also will not be. Let's see. Right. Well, days 1999, right? Time delta. Well, no minutes has no past actually. So you want to use maybe years. Do you have years? What do we have else? We have not something I usually use. You probably have to look up on total seconds, for example. Let's see what's happening here. Yeah, actually, so yeah, so this gives you total completely seconds with a floating point. If you want the floating point, so this would give you floating point results. Again, and this is not something you have to remember. Again, and not all of these functionalities can be remembered, but you can go through and look it up here, right? If you look at datetime, right, you need to see here, and you see what you are able to get, right? You have time, right? You have different abilities, right, to get in the time zone. Lots of things you can do with time, right? And there's some examples how you can work with calculations, and you can even do math with time dates, right? So looks like days is actually -999, right? There's some extra things you can do with it, so something might be worth checking out this particular library. Okay, so I will leave that in here, documentation for this, right? So usually use it for datetime now, right? We have a type now, right? I'll show it here. Like again, if you don't like this way of importing datetime, doing this long writing like this here, datetime now, you can shorten this up. You can use this syntax from datetime, import datetime as, well, dtime or anything else. The dtime could be dt, my time, etc. Right? This is something you choose as yourself. Basically an alias, right? So now then you have a shorter code, right? Again, completely optional, but something you want to do. So let's check weekday. So what I do here, like really now, this is really now, right? Again, dot, and I do weekday, right? Or get weekday. Is it weekday? Yeah, weekday. Notice it says built-in function or method. So this means that I need to add. So again, remember we talked about classes in our previous lectures. So this is basically an object based on our, well, since of course everything else in Python is object. So we have a method. We're calling again. Remember what's method? Method is a function, well, attached. You could say attached to this particular object, right? And of course I have no parameters, so I'll have something out. So this should be, I would say 2. So what does it do, right? Well, 2 means, that means it's a Wednesday, right? Because we start counting, well, Monday actually is 0 and Sunday is 6, right? So Again, you can look it up in the documentation. Again, but of course you can just experiment and see what the values are. And of course you can get things like this really now, let's say year, right? You get year, really now, maybe months, and so on and so on, right? So this should be 2022, and this should be 4, right? And so on. You can get more. Again, just use the dot notation to get useful methods and properties, right? Again, difference, weekday, this is a method, so you need a parenthesis. This is a property, meaning this is already made. So this object, the year is fixed. I mean, you could say we made a timestamp. It's like a timestamp. Think of it like a timestamp. Of course, there's specific timestamp abilities as well, but this is just could serve as a as a quickie timestamp. Okay, so again, you can see more about these. Could be quite useful. Okay, I don't know if we have math. Let's add some more things we want to do. Math. Do we have math? No, we don't have math. So let's do that. Let's say we need something more advanced than what's included. We know how to. We can do. Add one more code. Like, remember, we could do, or basic math was what things we like. 5 plus 3, right? Remember, or 5 times 3. 5 divided by 3. 10 divided by 3. 3, right? And 5. Those are things we could do, right? And 5 to the 3, right? Did we forget something? 5 minus 3, right? Okay. So something maybe else, but that's about it, right? The basics be included. Basic math included, right? But maybe we need something more, right? So, right? 815, right? So looks present, right? So this is this was without the reminder, right? This was a reminder. This was well, cube, right? I'll do 3, so this is exactly, right? So you can see it's 125, and then of course 5 minus 3, right? Basic math, right? This is our first lecture, right? So, but of course we want something maybe more, right? And then I can do again same idea. I do math dot, and I take a pick of what I need. Maybe I need a ceiling, maybe I need a arc cosinus, right? If you want my trig homework done for me, right? I do a ceiling, and I'll do maybe, so I ceiling will be what? 2, right? And floor, math ceiling, math floor, right? Again, I'm guessing, but of course I remember there was one floor. There should be floor. Yeah, there is floor function, right? I press tab. So as you can see, this will be, right? And so I'll show you this maybe 0, 1, right? And this will be maybe 199, right? You'll see that this is 2 and this will be 1, right? Yeah, you see? So ceiling, floor functions, and so on and so on. So most of these are pretty self-explanatory. Again, you just import and start using, right? What you need, right? Nothing complicated, right? Dot, and if you need something interesting like a factorial, maybe, right? Or right, we do, let's say 5, right? Will be 120, right? And so on, right? And maybe what else? What else is there interesting? Notice there won't be too many statistic. There's also separate power. If you need this more strong power, I usually use this, but there's also built in this function. Most of these are basic functions, right? Cosine, right, will be, of course, of say something. Is this going to be radians? What do you think? 3.14, right? Was there math pi? I forget now. Yeah, there's pi, right? Let's check. Yeah, -1. Yeah, so this is radians. So cosine takes radians, right? All right. So math pi, and I'm sure you know this math pi will be. It's another constant. I would have preferred to be capital letters, because this, of course, is meant to be a constant, right? Okay, but enough math. Let's move on to statistics, right? I don't know if I have statistics here. Do I have statistics here? No, I don't have statistics, so let's move on to statistics. We have plenty of modules to go through. Just to give you a taste and how much are we doing on time. We have plenty of time. So let's move on to statistics. import statistics, not surprising. Stat, I start typing, and again, a good well, code editor, code environment should pick up on this. This module exists, right? So now I get access to some statistics goodies, right? Yeah. So again, you don't have to import all these. You import only what you need, right? Only what you need. So let's import. What do we want to get? Maybe some. Let's say. Let's make some random numbers, right? Some random dice. Random dice will be maybe. All right, and I'll import. Well, I want to draw some dice, right? So of course I could do statistics mean of say range. 10, which should be 55, right? Well, let's see, 0 to 9. So average be 45. Should be 45, right? Should be 4.5, right? I assume so, right? Since from 0 to 9, right? Is that the case? That is indeed the case. Okay, and of course, well, let's get something more interesting, right? This is, of course, statistics, a short refresher statistics. Maybe you are already taking statistics course. We need some random. Let's play some dice. So we have dice, random. Oh, I do have random, right? So this is actually something nice. We will use that random later on, maybe. Oh, we have counter, right? Actually, yeah. So maybe we'll combine them later on. We'll get to the random as well. But let's see also how we can use it also with a counter, right? We'll have some useful, maybe some useful values. So let's import. There's a specific, very nice library in collections, Python collections, which is for, well, specific more advanced data types. And there's one I use almost daily. I just spoke to a big research in Norway. They also use quite a bit of this, right? If you're working with, well, it's such a simple library, but it's, or a sub-library or sub-module. Basically, it's a dictionary specific for counting items, right? So quite nice. I don't know if we showed you in a class, but so we import it. So we import with this syntax. So we import not the whole library, but just one module, right? Again, module is a single file. Basically, you can think of a single file, but actually a single class here. So counter class, really. So I pass my string to counter, well, class, right? A subclass, right? Class constructor, right? Let's see. So this can be any type of iterable. So this is amazing library. Well, amazing. It's simple things you could do it. You could do it by yourself, but again, it comes built in. So you see that A is 5 times and 2 is space is done 2 times, and so on and so on. Right. So for example, you can count most common words. A very, well, pun intended, common occurrence. Right. You have kick brown fox jumped over sleeping fox, and that's a wrap. So we're gonna count split. Remember, we are gonna split the sentence, right? So the words, right? We have to first split the sentence by white space, right? Otherwise, we'll just get letters, right? Otherwise, there's difference, right? This here, I give a string. Here, I give a list of strings. Split gives me a string into a list of words by default white space, right? So on most common words are, well, fox, a, and so on. Well, let's see if we can do some stats, right? Char count, right? Notice, yeah, I was going to show you if you gave a sentence directly, right? You'll see that space is most frequently used, a, and so on, right? You can see the word frequencies, right? So again, depends what you need, right? This really depends on what you need. But let's talk about some, let's do some stats. And I'm going to import the random module, right? If you need a specific random number, right, you can use a random seed. This guarantees that you will get same. Well, again, computers don't really give you a purely random data. They give you something called pseudo-random values, meaning they pick some seed randomly, hopefully from a universe somewhere, like from a I don't know, nuclear decay or lava lamps, right? To use as a seed, right? Lava lamp seed, right? Yes, internet secure. It's not a joke. Tom Scott has a nice video on this if you want, right? Because you need a process which is impossible to predict, basically, right? I think that's nuclear decays. There's a couple other things which you can't really do, and lava lamps actually qualify, right? So Cloudflare, right? You can check it out with this. I'll give you a link to this video. Maybe you
computers aren't.
Yes, so you can watch it later on. Yes, and so could be nice. And I'll give you a nice link here. Right. So shout out to Tom Scott. But so again, because computers don't really give you random numbers all the time. They have pseudo-random. They have certain, so they look random, but there is actually a method to the madness, right? But for practical purposes, meaning they repeat maybe after, I don't know, a good pseudo-random values repeat after a very, very long time, meaning you will never encounter a new value, right? But again, if you provide the seed, you will be able to see the start. So let's see. Okay, so random, see? It doesn't change. If I use this, right, then it will change, right? So we can pick a starting point, you see? Now it's a completely random starting point. But if I say, okay, start my randoms at this, right? So I'll be able to repeat. It's good for repeating certain things, right? But of course, sometimes you need, you might want to avoid this. Again, so this random seed starts the, again, it could be any number, 42, anything, pick your number, right? So pick your own seed, starting seed, right? Right. So it could be any number, of course, right? 42, 23, etc., etc. Right? Okay. So now we have these numbers, and I'm gonna load this 5. So again, notice something, right? So if I do it again, you see 5. It should be always 5, right? It should be always 5. In fact, I'll give it to here, right? So the sequence, right, will be always 5, right? But this one won't be 5 anymore, right? It will be 1, right? Because now it's, I mean, it's random, but in a specific order because of the seed. But okay, enough about the seed value. Let's see how we can use this, right? I want to actually make some counting, right? I want to make some dice throws and get some statistics. That's what I want to do. One of my favorite exercises is getting some dice throws, right? So I'll throw dice throws, and I will throw 2 dice. So it will be random rand int, right? Not bytes, but rand int. And I'm not gonna throw so rand int plus random rand int 16 again for in range max throws, right? And I don't have max throws value, so I will create one, right? Max throws is just a max throws, let's say 10,000, right? Why not? We can do more. So, and I need to close this parenthesis, right? Okay. Where's the problem? Oh, here's the problem here, right? It's not defined, so I need to add dot, right? We have a random library, random integer. So one of the things you should pay attention is random integer. It starts and is also included. So start on end is both included. Thus, this happens. Most libraries, like in most tools we use, usually in programming, you don't have the end included. This does actually include the number, right? So 6 is included. Okay, let's test it, right? Let's test it. Let's throw some dice and let's get some stats on this, right? We know already stats, dice stats, right? We can do, of course, well, let's see, statistics. Let's say mean, dice throws. What do you think? Statistics, mean, of course, median. Median will be, well, should be probably same, right? Dice throws, and we can also do statistics mode, which, if you remember from your statistics class, is the most frequent. This is one of those cases where it should be very similar, right? mode is most frequently seen item, right? It could be, in this case they will match here, here these values will actually be very close to each other, right? So what's my prediction? My prediction, this will be 7, right? Because I'm throwing 2 dice, right? So, well, this one will be probably around, also around 7, not quite, and this also will very close to 7. Yes, very close, right? Indeed, extremely close, right? So, why is median exactly 7? Because we take, we order the values and we take the median value, right? Okay, but let's get some more data. Let's get some statistics, right? We can do, well, of course, we can do also statistics, standard deviation, I believe, right? Standard deviation of this dice throws, and so on, right? Maybe something else as well. And bisection, well, we can do geometric mean and so on. I don't know if you can do geometric mean. It'll actually work. I forget now how geometric mean works, but let's check. And so on. It should tell me what it does, actually. I don't know if it's actually going to be meaningful. All right. What's happening here? Why didn't I do this? Dot. Maybe it thinks it has one, but maybe not. Maybe I'm not writing correctly. But okay, let's do this one. Just standard deviation 2.44, right? Which is the distance, right? As you know in statistics, well, the one standard measure of one statistic, you do there's the formula, right? You have the median. Well, you have the average. It measures how far the average value is from the mean. Okay, but let's get some more statistics. We can do things like counter, right? Dice count will be counter dice throws again, and we can see dice count, right? And not surprisingly, we can see that 7 is the leader, right? 7 is leader. So this is a dictionary, right? You can use this as like a dictionary, so you can see. And also you can do dice count, most common, right? So what's different? This gives you a list of tuples. This gives you a dictionary, well, with some extra benefits, right? So this is sort of a dictionary. This is actually a list of tuples. Right. Okay. Let's continue about some of the. Let's talk about some randomness, which might be useful for you. Right, so you have an alphabet, right, string of first 10 letters, right, and let's, again, it's extremely easy to make a mistake when you're writing your own shuffle algorithm, right? So, for example, right, so this might be useful, right? This forces original list of items to shuffle, right, in place, right? I can keep shuffling, right, and I'll get always. Right, and of course I don't have to be this. I can do the whole thing. Right, again you have all the letters. You shuffle everything. You shuffle 6 items, right? So you can see all the letters are shuffled. Right, so we can also do a random choice. Right, always get a random choice. Right, and depends how many items do you want. Maybe you want more. Maybe you want more. And we do random choice. Let's do k equals, maybe say 3. So what will happen? Oh no, I forget now how it was. K equals, let's see, choices. That's a single choice. That's a single choice. Yeah, sorry. So k, 3 choices, right? You have 3 choices. fx, and the question is, will it repeat? The question is oxy, right? Right? This actually does not repeat, right? No replacement, right? So this is what's this gives you a new list, so you can do a new alphabet, right? And get all. Well, looks like it repeats. Right. This is the old alphabet, right? And my alphabet, new alphabet. So you don't actually. You have different you have different different. This is actually with replacement, right? Notice AAA, right? So this actually might not be the choices, right? There was another one, I think there was. So this is not without replacement, right? So you can have multiple, right, picks. Not something, maybe you don't need this, right? You OAA, right? So how would you avoid this, right? Let's thank you, Tom. And let's see, in the randomness, right? We have a randomness, random. There we go. Right, choice or sample, right, without replacement. Yes, Apple peer, right? So this is choice. Sample is probably what you want. Yes, sample, not choice, right? So this is actually what you want. So we can compare it, right? So that this is replacement with repeats, right? Right. Again, there's no guarantee that there's no repeats here. Like I'll do 10, and we can do also check. Right. So this should have some repeats, right, and choices, but sampling again. So you have to check. Of course, yeah, 2 L's, of course, yeah. So, but if you want no repeats, new alphabet, no repeats, then you would use random sample. You know, I'll do my alphabet, right, on K equals len of my alphabet, right? So that's the difference. Sample and choices, right? Something might be alphabet, no repeats. Okay, so that should be, hopefully by now we have some idea about how randomness function works, and let's move on. Our time is starting to run out. We want to look at the work with directories, right? So let's see a simple thing, how to look up what you have in your directory. Well, turns out I don't have much in my Google directory. This is, in this case, this is my Google Colab directory, right, temporary. So you can check it out here, and that is in fact, you can see there's a configuration hidden file, and we see sample data. But okay, we have some cool sample. This comes for free from Google whenever you load it, right? California housing and so on. So how would you get this? Right, first of all, let's get the current working directory. And we are in content, actually. This is a Google library, right? So what I really recommend is using a pathlib library in your module. So from pathlib, import path, right? And let's see how we can read some files. And I'll show you an idea. Let's say I am here, right? I am in this directory. I want to read this folder, and I want to see only CSV files. So let me show you how to do this. CSV files equals F for F in path. Again, so I'll do this, right? Local, right? And I'll do, no, not like this, but sample data, right? So subfolder on glob. I'll do a glob, meaning a wildcard, CSV, right? If F is file. I mean, it's highly, this part here is highly unlikely that this is actually going to be not a file, but, well, you never know. So let's see what we picked up. Did it work? Yes, it worked perfectly, right? So, well, how about if I wanted to go globally, right? Let me upload maybe some CSV file, right? And maybe I could upload some test file here on, or create one. Let's create one. Maybe can I make one here quickly? Well, we can do something like this with our writing files, right? We did do a session on writing files, but okay. But the idea is this: I can do also a global one, global recursive search. All CSV files, right? and I could do this F for F. In path, I'll do current, right? I'll do global. Reglob, right? Notice this is a recursive search. If F is file, again, if file is not really recommended, I mean I mean you probably get away with this is not file, but this is all, so this will provide, right? So it turns out it's exactly the same result, but this is recursive, right? We start here and we go deeper, right? We can go through all subdirectories, right? So that's the difference. You look in here, we look in specific, subdirectory, right? Here we go through all, right? Even if I had the file here, you could still see the files, and then you could open up this file using our regular libraries. In fact, well, we have a little time, we have CSV library, which is not great, but it is included. I'll show you. It is, let me see, search, right? CSV, but let me see, I have not used it in a while. CSV, right? Let's see, right? You might need this, right? It's also included, right? So Python CSV library, right? Pandas is what I usually use, right? But this is also possible, right? Import CSV, and we can open up. So here it is, right? And we can see basically we'll have a reader, right? CSV reader, and we can tell what CSV makes things very difficult is that you need to tell what the delimiter is, right? Comma or tab or space or something else, or what the quote character is. How do you quote things, right? So not as easy as you would think, right? Usually external pandas is preferred. We shall look in maybe next or lecture after that, but for smaller tasks, CSV library might be enough, right? So here's the link, right? So let's look at the example. And this is one I don't use too often, but again, it's possible. Let's see what we have. So we'll have right, and I need, of course, spam reader, right? So instead of opening up eggs, I don't have eggs in my I have something like California housing test. Okay, let's do that. Test, let's do test, right? So how would I do this? Well, I have here, right? I have all CSV files, right? 0, right? Right, so this works. So this is my path. I could do it by hand, of course, if I knew this, but let's say I do this. So I'll do this first one. Come on. Getting tired here. Control Z. Control V. Okay. Well, I don't know what I assume it's a comma. Well, let me take a look. I don't know if you can say. I'll download back, of course, but I don't want CSV. CSV is not what I want to do. I mean, do not use Excel. Is horrible for these type of files, but I will show you with a notepad, right? Right, this looks like, okay, so this is a quote and this is a comma, right? Okay, looks good. So what do we use? We use, right, new line. I'm not sure if I need new line here. We'll use, delimiter will be comma, and quote will be this. I believe these are default, by the way, these are default, I believe, right? Right, from reader. Well, and remember this is a reader, so my data equals list spam reader, right? Spam reader is stream basically, right, of data, right? You know, so we might need to commit it to memory, okay? So right, so it depends what you need, of course, right? So new line, I assume this should be like this. Let's check out what happens here. I'm not sure it will be correct, but let's run it. It worked. And my data, len, my data. Oh, 3000 entries, excellent. So let's look at the first 2 or 3 data points, right? My data, first 3 points, right? So yes, so this is a column, and then you have the date. Looks pretty good, right? You just need to convert these to, obviously you need to convert these to floats, right? And you can start working, but we'll see that this, so we have our data. So we have our data. We would need to convert the strings to numbers again, but again pandas library would be better suited for more advanced analysis, right? Okay, so that's CSV library. This is a standard again, so you can open and save files if you need with this library. On for the last few minutes, let's check what else is something useful. Well, we'll talk about, there's internet access, there's data, there's a zip file. You can convert everything to zip. By the way, yeah, let's check. This one might be useful, but like this was not a zip file. Yes. So I'll show you example. Yes, like something like this. You can write, this is right. So we can open up multiple files. I'll show you maybe one last thing. Python zip folder, right? Quickly. And this was, I think it was standard library, right? Yeah, shell utilities. This was nice. This is very nice, right? So this is still included, right? But older. But let's check newer version 3.10. Yes, it still works. Okay, so this still works. Let's check. Very nice. There's other ways of doing it, but you can do this, right? Again, so you just have to look through pretty much anything you can think of is available as far as file operations. But let's do that. So show you. So I have my zip files, right? And let's see how was it on this example, right? So, right. So name, type, right, on the folder. So let's see. So import on shell utility make archive. So this obviously is going to be sample data, right? Zip, and we'll call it well, we'll call it something my archive, right? Let's see what happens. Let's see, this works still. No, shell tool doesn't work. It has to be reversed. Sorry, sample data. Let's see. Sample data, and let's see. Yes, this is my zip. My zip file, right? Okay, yeah. Okay, my data, my zip archive, right? I think this should be work now, like. And yes, it is in content, right? My zip archive, and it should be here, right? If I refresh this part here, it should be, yeah, here it is, and you can download the zip, right? So very easy to use, right? If you need to zip a bunch of files, right, from some project, right, extremely easy to use. And there's also a zip file for more advanced. There is also zip file for more operation. Standard library for more operations with zip files, right? So this could be nice. Also, there's of course extraction as well. All right. So I hope you got a nice idea of what well, the variety of things you can do. There is also like the network operations. Again, many other operations that can be done with standard library. Things we didn't cover because just due time. Again, we can talk about this for hours, right? But again, some things like, for example, SQLite database access. Maybe we'll get to that maybe later, right? Maybe right? Some things might be important, like emailing, or well, we'll talk about JSON, right? XML parsing might be useful for you. There's also a nice library for, well, making little games, right? Tutorial graphics, also for graphical interfaces if you want that. Some things are included, some nice things included. So I I hope you got a nice little taste, at like appetizer of what Python standard library can do, but that's not all. Well, in the following lectures we'll be working with some nice external libraries which give even more power to Python. Alright, thank you, and we'll continue in the class.